Now let's talk about finding projects. So there are a couple different ways you can find projects that would suit you. One thing to do is scan previous projects for ideas. You can take a look at the ones in a previous iteration of CS3244, especially the project showcase from 2018 in the first semester, where we took the time to curate some of the best projects after the course was over. You might also visit other universities' projects too. For example, Stanford has a very famous machine learning course, and they also archive their projects. You could also, and I certainly encourage you to do this, talk with our project TAs. They're here to guide you, but also grade you. So why don't you get their ideas for projects as well? In particular, we have a bunch of graduate students who are in charge of many of the components, and one in particular, his name is Heng Chan, will be the project lead TA. He's the project coordinator. All of the other undergraduates that you see below here are also our project TAs. They will be responsible for grading and championing your projects, and likely your project will be assigned to one of them for guidance. You should talk to your project TA on a constant basis, not just in the interim consultation, if your team's bandwidth allows. So like I said earlier, there are lots of caveats to coming up with a good project, and I'll just recap them briefly, is that you need to make sure you have enough computational resources, you need to have enough data or find data, because it's very hard and difficult and time-consuming to construct your own data sets. And we don't want you to just go with a state-of-the-art paper and try to replicate it. That's more of an engineering work that you might do in a company or internship. We really want you to take this from an academic perspective and try to learn something new. So try to look at the analysis of how the learning system works and try to diagnose how you might fix some of its shortcomings. Now for project resources, there are lots of things out there, but some of the most important components are, again, the compute necessary to carry out your project, looking at previous videos to get an idea of how that is constructed, and data sets that you'll need to actually execute your project. So in our school, we're lucky enough to have a fairly good compute cluster, and many of the compute engines that you can see here, you will be able to access through the Sunfire accounts that you might get coming from the course. If you have any questions, you can ask our project TA for help. Now, many of these machines come with GPUs already installed. So especially if you're taking a deep learning project, be aware and utilize these resources early. They do take a significant amount of ramp up to learn how to use. If you even have more bandwidth than that, I suggest you take a look at Amazon Web Services, or AWS. They have a system called Elastic Computing, or EC2, which you can use for this course. So if you wanted to get both machine learning experience as well as cloud computing experience, I highly recommend you and your team try to enlist on AWS. We have credit to the tune of $10,000 to share with all of you in the class. So in compiling your own videos, we suggest that you look at other sources out there. There are some that are pretty good, such as the 2-minute paper site that introduces a scientific paper in under 2 minutes. There's also data sets and other pieces of information out there. For example, the dataset search from Google comes up, you can type whatever you want in it. So here I've typed the words SMS and NUS, and we've come to this page which lists the dataset that my group compiled for SMS, or short message service. Now that dataset was listed by Kaggle but picked up by Google search. But what about Kaggle itself? So Kaggle is a very well-known data science community, which house competitions mostly, but they also have, aside from competitions, data sets, and notebooks. Notebooks are basically kernels or code that you can run to accomplish an algorithm. I highly suggest you take a look at this website if you don't know it already. There's, of course, many other websites that you can go to. We've already alluded to some of the Stanford websites, so you can find project posters and reports for some of those that are open.